So hello everyone, in this audio class we will discuss the 20 most important questions from the chapter Origin and Evolution of the Earth from the chapter 2 from the book Fundamentals of Physical Geography. These questions and answers will be very much important for your upcoming KVS and NVS PGT Geography interview. So let's get started with the question number 1. How do scientists explain the origin of the universe? So, according to the Big Bang theory, the universe originated about 13.8 billion years ago from an extremely hot and dense state called a singularity. The explosion led to the expansion of the universe, which is continuing even today. For example, just as a balloon expands when air is blown into it, the universe is expanding and the distance between galaxies is increasing. Next question, what evidence supports the Big Bang theory? So, the strongest evidence is the galaxies that are moving away from each other, showing that the universe is expanding. This was observed by Edwin Hubble. For example, if dots are drawn on a balloon, the dots move apart as the balloon expands. Galaxies behave similarly. Next question, what is meant by expansion of the universe? So expansion means the space between galaxies is increasing continuously. It does not mean that galaxies themselves are moving through empty space. Rather, the space itself is expanding. So for example, raisins inside rising bread move farther apart as the bread expands. Next question, what is the Nebular Hypothesis? So, the Nebular Hypothesis was proposed by Immanuel Kant and later modified by Laplace. It states that the solar system formed from a rotating cloud of gas and dust called a nebula. Next question, how is the Nebular Hypothesis different from the Big Bang theory? So, the Big Bang theory explains the origin of universe and the Nebular Hypothesis explains the origin of solar system. So, Big Bang, entire universe, Nebular Hypothesis is related to sun and planets. Next question, what is the modern theory regarding the formation of solar system? So, the modern explanation is the solar nebula disk. According to this theory, a rotating disk of gas and dust collapsed under gravity and formed the sun and planets. Next question, what is accretion? So, accretion is the process by which small particles collide and stick together to form larger bodies. These bodies eventually became planets. For example, a snowball becomes larger when more snow sticks to it. Next question, what are planetesimals? So, planetesimals are small solid bodies formed by the accretion in the solar nebula. These planetesimals join together to form the planets. Next question, why was the early Earth extremely hot? So, the early Earth was hot because of gravitational compression, radioactive decay, frequent collision with other bodies. Therefore, Earth initially existed in a molten state. Next question, what is differentiation? So, differentiation is the process through which heavier materials moved toward the center and lighter materials moved toward the surface. This led to the formation of core, mantle and crust. Next question, why is Earth's core rich in iron and nickel? So, iron and nickel are very heavy elements. During differentiation, these heavy materials sank towards the center of the earth and formed the core. Next question, how was the lithosphere formed? So, as the earth cooled, the outer molten layer solidified. This solid outer shell became the lithosphere. The lithosphere later broke into tectonic plates. Next question, what is plate tectonics? So, plate tectonics is the theory that explains movement of lithospheric plates. It is responsible for earthquakes, volcanoes, mountain buildings. For example, the Himalayas were formed due to the plate collision. Next question, what was the composition of the primitive atmosphere? So the primitive atmosphere mainly consisted of hydrogen, helium. These gases were later removed by solar winds. Next question, why did Earth lost its primitive atmosphere? So the primitive atmosphere was lost because of strong solar winds coming from the sun. The Earth's gravity at that stage could not retain these light gases. Next question, how was the secondary atmosphere formed? So the secondary atmosphere was formed through volcanic outgassing, that called degassing. Volcanoes released water vapor, carbon dioxide, nitrogen, methane. Next question, how were oceans formed? So as the earth cooled, water vapor condensed into liquid water. This accumulated in depressions and formed oceans. For example, water droplets form on a cold bottle when water vapor cools and condenses. Next question, how did life originated on earth? So scientists believe life began through chemical evolution. Simple organic molecules combined to form more complex molecules, eventually leading to living organisms. Next question, what were the first forms of life on the earth? So earliest life forms were simple prokaryotic organisms. They appeared about 3.8 billion years ago. Examples include primitive bacteria-like organisms. Next question, how did photosynthesis change the earth atmosphere? So photosynthetic organisms released oxygen into the atmosphere. The increase in oxygen made complex life possible, led to formation of the ozone layer. Today, for example, green plants continue the same process by releasing oxygen during photosynthesis. There is a final grand question, bonus question. Why is the study of origin and evolution of the earth important for a geography teacher? So the study of the origin and evolution of the earth helps us understand how the present earth system developed. It explains the formation of lithosphere, atmosphere, hydrosphere and biosphere. It also helps us understand plate tectonics, mountain building, earthquakes, climate evolution and development of life. Therefore, it provides the scientific foundation of physical geography and helps students understand the earth as an interconnected system. So, thanks for listening. Keep listening for further audio classes. Thank you.